Hello class. 3.2, we are given an introduction here to functions. So, introduction to functions. Alright, first of all, we want to talk about the two words, the domain and the range. Every function has a domain and range. And the domain is simply a list of all of the x coordinates, or the x values, I should say coordinates, so we think of it as the points on an xy plane. And I like to think of that as the input. You just saw in 3.1, when we wanted to graph it, we put in an x value and got out the y value. So that helps me. And then, so we'll put for our range, the range is the y values, or the y coordinates. And it is the answers we're going to get, or the output. So, if I ask you, for example, to find the domain and range of, let's do an absolute value, like we just graphed. If I ask you to find the domain and range of that, now these points mean that it keeps going forever and ever and ever. So if I were thinking about, say I just randomly picked 3 right there, I can see that, oh, it corresponds to a value, and 3.1 and 3.2, every number does, up to positive infinity. And the same is true, that's supposed to be straight, but the same is true, I don't know why it wants to curve. The same is true on the left, on the negative values. So every x value is in the domain. So let's tell them that. Let's say our domain is every x value from negative infinity to positive infinity. But the range, however, the y values on that graph, if I were going to list those, they would start right here at 0, right, on the y-axis, and they would go up. I would have a corresponding, in fact, I would have 2 corresponding values to every y value above the x-axis. But down here, I would have no corresponding graph. So the range actually starts at 0 and goes to infinity. And we've talked about interval notation. It would include 0, so I'm going to write brackets there. So 0 to infinity. Now, with your definitions, let's talk about a relation. A relation is just any set of ordered pairs. If you're given some ordered pairs, that's a relation. And it doesn't matter, they don't have to meet any qualifications. But to be a function, this is a little more specific. Every x has to correspond to exactly one y value. So if I look at the graph we just drew, no matter what x I pick, I could do positive 1, positive 2, positive 3, I would only have one corresponding y value, wouldn't I? Negative 1, negative 2, negative 3, they again would only have one corresponding y value. And so this is an example of a function. Now there's an easy way, kind of a shortcut to decide if something's a function or not. And that is, well, first of all, let's do this. This is a tinge harder. If I gave you a set of points, so let's say I gave you 1, 6, 2, 8, 0, 3, and 0, negative 2, and I wanted you to tell me the domain. You know that to tell me the domain, you would list all the x values, right? So, and you don't have to list them twice, and technically we should go in order from smallest to largest. So I would say that it's 0, 1, and 2. Now if they wanted the range, I would tell them all the corresponding y values, 6, 8, and 3, and negative 2. And again, trying to go in order, we would go from smallest to largest. That is our range. Now the question is it a function? So, does every x correspond to exactly one and only one y? And you can go, oh, there's a 0, that's an x, that corresponds to 3. And then that same x, 0, also corresponds to negative 2. So that is 2 different y values. So it is not a function. So if one x has 2 different y's, it is not a function. Now, another thing they'll do is they'll give you some graphs. Let's do a random line. Let's give you a parabola. Let's even talk about a sideways parabola. We'll talk briefly about those. Let's talk about, this is a y cubed function, so it's got a little curve in it. And we could even have vertical lines, and we'll even talk about horizontal lines. So all of those are different graphs, and we're going to decide if they are a function. So your homework might say, are those graphs functions? And you need to look at them and decide if every x corresponds to exactly one y. So looking at the line, no matter what x you pick, it's only going to correspond to one y value, isn't it? It won't correspond to two different y values. So that's an example of one that is a function, but guess what? There is a shortcut. A shortcut is called the vertical line test. The vertical line test says that if you draw vertical lines through this, so just think in your head, maybe I'll actually draw them on this one, but in your head you'll just do them imaginary lines. These imaginary vertical lines, no matter where you draw them, how many times did they hit the function? How many times in this case did they hit the line? And you can see that they only hit one time no matter where you draw it. It just hits once, doesn't it? And if it passes the vertical line test, and that's what you mean by pass, it passes if it only hits it one time, then it is a function. So this passes the vertical line test, so it is a function. Let's see this one. Does every x only correspond to one y? If I pick this x, I can see, oh, it only has one y value. And does it pass the vertical line test? It does, doesn't it? So this is also a function. Now, what about this one? Here's an x value, and it corresponds to both this y value. Oh, and it also corresponds to this y value. And look, does it pass the vertical line test? Our vertical line hits it twice, doesn't it? Over here it doesn't hit it at all, but over here it hits it twice. So it is not a function. It does not pass the vertical line test. How about an x cubed? Does it pass the vertical line test? Imagine drawing vertical lines in that. And you can see that they would only hit it once if I had drawn it good and it didn't have two lines. So it is a function. What about a vertical line? All these don't hit it at all, but oh, the one vertical line that you could draw right there on top of it would hit it infinite times. So a vertical line is actually not a function. But a horizontal line, imagine drawing vertical lines all the way through it, and you can see it will only hit it one time. So it is a function. Okay? Now, when you know if something is a function or not, they will probably start to use function notation. If I told you that y equals 4x plus 5, we just graph that. We know that that will be a line. And if I want to use function notation, I can replace the y value with this, and you say that f of x. So I say f of x, meaning f of x is y. The f of x is the y value. So you have to remember that f of x is the very same as the y value. And so if I gave you something like this, f of x equals 4x plus 5, and I ask you to find f of 0. What that notation means is they want the y value, because f of x is y, but they want it when x is 0. So I come over here to my function that's given to me, and wherever I see an x, I put a 0. Sorry, I drew that line too crooked. So I now have 4 times 0 is 0, plus 5 is 5. And some people want to separate f of 0, and you never separate it. This is locked together. You never like divide by 0 or divide by f. This is just the same as y. So what we just said is that the y value is 5. And it's 5 when x is 0. So some people go, why do we have to use another notation? But the reason is this. It actually is helpful. It tells you a lot of information about the function. It tells you that on this line, you have this point over 0 up 5. Let's use the same function and let's find f of 2. So if I wanted f of 2, I go to my function f, and wherever there's an x, I put a 2. So I have 4 times 2 plus 5. And we know order of operations says I multiply first, and then I add. So I get 13. So once again, we haven't separated that. That's still intact. What we're saying is that y is 13 when x is 2. So we know now 2 points on that line. Now, f of x is the most common notation, but they can actually use whatever they want. They could, for example, use g of x. They could say g of x equals 3x squared plus x minus 2. So let's use that. Now they might say find and give you, for example, g of 3. This is kind of big. So if I'm finding g of 3, I go to my function g because it's labeled g, that's its name. But wherever I see an x, I put a 3. So I have 3 times 3 squared plus 3 minus 2. And you know that x would probably look like this. That parenthesis would probably look like that. But we know that we do exponents before multiply. So I take 3 squared, which is 9, and then I times that by 3. And we know we do multiplication before addition. So I have 27 plus 3 subtract 2. And now, order is optional. 27 plus 3 is 30. 30 subtract 2 is 28. And the whole time, my g of 3 stays intact. So I now know what point. Do you know what point you know? The y value equals 28 when the x value equals 3. All right. Another thing that they'll do in your homework is have you practice finding the domain and range. So let me give you a few graphs again. Let's say I give you this graph. And it's randomly stops right here and it goes like this. And let's give you this graph. And how about a line? And the last one we'll do is a circle. Okay. What we want to practice finding is the domain and the range. So let's see if we can find the domain and range. Okay. So if I were to ask you the domain here, I need to tell them all the x coordinates that correspond to a point on that graph. So if I were going to name it, let's say our first one, let's just say it's -2, 3, that point right there. And then I would have -1.9, -1.8, all the way to -1. It would keep going to 0, and then it would keep going 1, 2, 3, 4. And you know what that arrow means? It means it never ends. So it's going to keep going forever. And since it goes up, we know that my x values will just keep going. So we can tell them that it starts at -2, and we tell them it includes -2 by using a bracket, a square pointy bracket, and we're going to go all the way to infinity. Now how about our range? What y values does it include? So now look on your y-axis, and this isn't very, I didn't draw it very perfect. It should actually touch right there because we don't know if that's 0.1 or 0.9 or what that is. So it should touch right there, and they'll make them nice and clear for you. So you can go, oh, I start at 0 and I just keep going. Every single other point is above 0. So again, we include 0 with a bracket, and then it will go up to infinity. How about this one? What's the domain now? Again, look on your x-axis, I don't use any of these x values. 0, 1, still not using them. Oh, I start at 2. And then every value after that corresponds to a y value. And in fact, 2 y values. So we know it's not a function, but it still has a domain. The domain will start at 2 and go forever to infinity. The range, now what y's will correspond to your graph? Well, if this arrow means it goes up slowly, but it keeps going up and up and up and up forever, it's going to go all the way up and it's going to go all the way down. So this is going to be negative infinity to positive infinity. And we know that we can't include infinity, so it always has a parenthesis. Now a line, and I could draw any random line, is going to actually use every x value and every y value. So they're kind of easy. Unless it's vertical or horizontal, they will always be negative infinity to positive infinity for both the domain and the range. Alright, now let's come label our graph a little more clearly. So, in my graph, let's see. Alright, I didn't draw it very well, but if I want to name my domain, I need to know all the x's on this graph. So use your x-axis and look, oh, I see it starts at 1, and then it goes 2, 3, 4, all the way up to 5. And all those values correspond to a point on your graph. So that will include 1, and will go all the way up to 5 and include 5. And the range, try and do the range, even though my graph is awful, try and do the range before I tell you. And I'll draw my graph a little clearer. That should be the same up and the same down. Oh, that's awful. But you can see it's supposed to start at -3, and it should end at +3. So wherever your graph is, no matter how awful the graph looks, all you're telling them is what y values it includes. And in this case, it goes from -3 to +3. So hopefully that will help you. And this section typically is on the final exam. Typically, and you've seen other things like drawing lines that are on the final, but you have to find function values, and I've even seen questions on tests that ask you domain and range on finals. And of course, on our chapter test, there will be one. So make sure you do every problem, and if you need more, don't hesitate to do more. The homework is the minimum of what you should do. If you need more, don't hesitate to do more. Good luck, you guys.